Hello,
Yes, ma'am. It's
hello,
complete.
hello.
हाँ मैम आ रही है, आवाज आ रही है।
Hello? Dear participants, good afternoon to one and all. As the number of participants have joined are not good enough, we'll wait for a few more minutes for the other participants to join. Kindly be patient and wait for a few more minutes, then we'll start off with our first session of the day after some time.
Hello, good afternoon, all participant. I just introduced Josna Madam profile. Josna Madams, a highly experienced technical leaders with over 16 years of specialization in electronics, VLSI, and embedded system design. Josna has proven tracks records in driving innovative solutions across a wide range of technology, including the radar system, reactor control system, digital signal processing, and control automation system. Currently serving as a manager technicals in the reactor project divisional at Electronic Corporation of India Limited ESIL. She brings a wealth of knowledge in high-speed data acquisition VLSI design using the FPGA and embedded system development. Educational profile, she did MTech in VLSI Embedded System, Coaching University of Science and the Technology, BTech from in Electronics and Communication, Coaching University of Science and Technology. Key expertise, VLSI design for high-speed data acquisition and processing, especially for radar and reactor control system, embedded system design, digital signal processing, and control automation system. FPGA-based design for efficient data processing. I just welcome, ma'am. Please start your session.
Thank you, ma'am. Am I audible for you? Hello, ma'am. Am I audible?
Yes, ma'am. You are audible.
Yeah, okay, thank you. Is it like an interaction section? Can I ask some questions and you will respond it?
Yes, ma'am.
Okay. Ma'am, my presentation, can you share my presentation?
Sure.
Yes, ma'am. You can share your presentation.
I have to share my presentation.
Okay.
Okay. 1 minute. Hmm, yeah. Presentation, yeah. Can you see this presentation?
Yeah, it's visible.
This screen. Is it clear, the presentation?
Ma'am, can you
Full screen.
Full screen. Okay.
Yeah.
ma'am, can you download the file and open it in the PDF, ma'am?
Okay, okay, fine.
Or the presentation?
PDF you want to me to share? Okay.
No, ma'am. You can directly open the presentation also.
Oh,
The screen shared was from the Gmail account.
yeah, yeah, yes, yes. Yeah. Now it's okay. Hello? It's clear now?
Ma'am, please
Yes,
click the
madam.
enable editing in the top.
Pardon?
Please click on the enable editing.
Okay. Yeah, yeah, yeah. Now it's okay?
Ma'am, your screen sharing has been stopped. You have to share your screen again.
No? You can see the screen now?
It's visible, ma'am. Yes.
Yeah, okay. Yeah. Good afternoon, everyone.
Ma'am,
Myself.
kindly double click on the first slide, na?
Pardon? Yeah, of course. Okay.
Excuse me, ma'am. Ma'am, go on there. Full screen.
Okay. You're getting repeated echo from my audio?
No, ma'am. The screen which we can see is the presentation window. In that presentation window, all the slides are being shown and nothing is readable.
1 minute. Let me see what happened. This they are able to see. This you have to remove.
Yes.
This
Some
first.
slides, sir.
Yes, ma'am. Now it's clear, ma'am.
Okay, okay. Shall I start?
Yes, ma'am. You can start the session.
Okay. Myself Joshna. I'm working with ECL from past 16 years. I'm basically a VLSI designer and embedded system designer. I work for nuclear reactor project control at automation system, especially for nuclear power plants and submarines power generation also. I will ask you some questions. What are the different methods of power generation? Are you aware of in India? Can anyone answer me?
Solar power.
Solar, yeah. What are the where you are getting power from? In Hyderabad? Pardon?
Ma'am? Yes. Participants, please respond to the ma'am question.
Because I don't want the section to be boring. It is lunchtime. That's why.
Hello, good afternoon, ma'am.
Good afternoon.
We can also generate it through wind.
Wind, yeah. Wind.
And thermal power plants,
Thermal
hydro
power.
power plants,
Hmm. Who is
and pure
generating maximum power
thermal in
no,
India right now.
right now in India?
After that, hydro.
Actually, power generation capacity is more for nuclear.
Okay.
But India, due to the more population, we are not able to implant more power plants in India. Because to implant a power plant, we need a vast area.
Okay.
That's why, and one more thing is, in nuclear power plant, we are using uranium.
Yes,
Which
ma'am.
is
Uranium 235.
235, which is very much radiation hazard one. That's a protection that we need a vast area to protect, isolate from human beings. And we have generally protection cells also in that. But what is the reaction happening in nuclear reactors? For
Nuclear
generation?
fission.
Pardon?
Nuclear fission.
Fusion, very good. Nuclear fusion, what will happen then after nuclear fusion? It will generate what?
Actually, one neutron will insert and chain reaction will start. Na? That's all.
Chain reaction. But chain reaction will generate what heat? that heat energy will boil the water, and that boiled water will the fusion reaction will boil the water, and the heat generated will turn the turbines actually.
Yes, ma'am.
This is what is happening in nuclear reactors.
Yes.
And do you know what is happening inside sun?
Sun.
It is the biggest power generation unit. Actually, how much amount of power sun is generating? No. What is the reaction inside sun? Sun. Our sun.
Yes, ma'am.
Sun. It is fission reaction.
Yes, yes.
Fission reaction. What is a substance used? What is the element used?
Helium.
Hydrogen, which will combine to form helium. That is happening in the fission reaction. That means what you are using is inside sun, we are having hydrogen actually. In our country also, we are trying to, we are doing many experiments. Actually, we are also part of that for producing similar energy of sun fission reaction, actually using hydrogen. 33 countries together, we are trying to generate. We are establishing a lab in Russia actually. A very big lab, which will generate almost a similar power of sun, so that we need not in future we need not need any other resources. And this is also very economic friendly since we are using hydrogen. This is one of the, and that experiment is carried out by ITER. You can search in net about ITER, more about ITER, and you will come to know what is happening in that. Now, since I have given this example just because my topic is also like hydrogen economy, that means energy is generated using hydrogen. That's why I given a just introduction. Do you know 1 kg of hydrogen can generate how much power? 1 kg of hydrogen can generate 14 kilowatt hour power. That means how much unit of power each person is utilizing their home electricity bill? No, how much unit you are getting? Can anyone? You'll see in electricity bill how much unit you are using. Pardon? I didn't get any response. Who is paying your bill? Hello, is anyone there? In my house, I am utilizing around 300 units of. Hello? Okay. 1 unit is nothing but 1 kilowatt hour. And 1 kg of hydrogen can generate 1 kilowatt hour. In my future slides, no, I will ask you this question again. Okay, first we'll see my topic of presentation is hydrogen economy and fuel cells. First, we have to generate hydrogen, then that hydrogen is used in fuel cells. That's why it is correlated. Then hydrogen economy refers to the system where hydrogen is used as a key energy carrier. This economy aims to utilize hydrogen for various applications, including transportation, heating, and electric generation. The transition to hydrogen economy is seen as a crucial for achieving sustainable energy and reducing carbon emission. Next slide. What is the importance of hydrogen? As you know, it is the first element of the periodic table. It is the most abundant element in the universe, and its density is very low. It can produce for various resources. It can be produced from various resources like water, natural gas, and biomass. Hydrogen can be stored and transferred efficiently, making it versatile for different applications. These are you can see the list of elements which is most abundant is hydrogen. Next is helium. Next oxygen, carbon, neon. Just go through it. Next, hydrogen. How hydrogen is produced actually? Hydrogen can be produced through the method called electrolysis, which uses electricity to split water molecules. In the diagram, it is clearly shown water molecule is split into 2 molecules of hydrogen and oxygen. And the hydrogen is stored in that hydrogen collection tank. Steam methane reforming is the most common method involving natural gases and producing carbon dioxide. Steam methane reforming method is having the disadvantage it also emits carbon dioxide. And biomass gasification is another method converting organic material into hydrogen-rich gas. There are different types of hydrogen. There are categories into different types like gray, blue, green hydrogen. You can see gray hydrogen is produced from fossil fuels without carbon capture, resulting in high emission. Here, the inverse, actually, we have to take buy fossil fuel from outside. We have to import the fossil fuels. Then we have to generate hydrogen, but there is no compression of carbon dioxide. That's why it's gray. It is called as gray hydrogen. And green hydrogen is produced using renewable energy, making it the most environment-friendly option. Here we are using renewable energy sources like solar, wind. From that we are generating hydrogen. That's why it's called as green hydrogen. Now more about green hydrogen. We'll concentrate on green because everywhere in India also we are everywhere in the universe we are concentrating on only green hydrogen, not on any other thing. Grey hydrogen since carbon dioxide emission is more. Green hydrogen is produced through renewable energy source, making it an environmentally friendly. The use of green hydrogen can significantly reduce greenhouse gas emission like carbon dioxide. Advancement in electrolysis technology are improving the efficiency of green hydrogen production. You can see in the diagram, you can use renewable electricity sources for electrolysis and generation of hydrogen. Hydrogen is used in pharmaceutical, medicines also we have some hydrogen content. And in fuel synthesis, fuels for aeroplanes, sea, ships, transportation vehicles and all. Slide. I will see what are the challenges in the hydrogen economy. The infrastructure for hydrogen production, storage and distribution is still under development. We need a huge, first time investment is very high for hydrogen production. High production costs, particularly for green hydrogen, poses economic barrier. Safety concerns regarding hydrogen storage and handling need to be addressed effectively because hydrogen is storing of hydrogen because of its low density. Storing of it is very difficult. It is highly flammable and it can cause even explosion. Are you able to understand?
Yes, ma'am.
Yeah, okay. I'm not too fast now.
No, ma'am. No, ma'am.
Okay.
Yes, okay, ma'am.
Yeah, okay. Innovations in hydrogen technology. What are the different types? Like research and development in hydrogen technology are rapidly evolving, yielding new solutions. Innovations include more efficient electrolysis method and advanced fuel cell designs. These advancements are crucial for reducing cost and increasing the viability of hydrogen applications. What is the future of hydrogen economy? Hydrogen economy is expected to grow significantly driven by technological advancement and climatic policies. Innovation in hydrogen production, storage, and fuel cell technology will enhance efficiency and reduce costs. Collaboration between public and private sector will be pivotal for realizing the potential of hydrogen. Like we are having collaboration with Russia for generation of hydrogen. I will give you some case studies. Successful case study demonstrate that viability of hydrogen is in various applications, including transportation and industries. Examples include hydrogen-fueled public transport system in cities worldwide. There are many public transport. These case studies provide valuable insights and lessons for future hydrogen projects. And hydrogen is also used in industrial application like refining petroleum, producing ammonia for fertilizers. Hydrogen can be stored in the form of one byproduct will be ammonia also. It can be used in fertilizers for production of hydrogen. It serves as a reducing agent in metallurgic process, helping to decrease carbon emission. Industry sector is exploring hydrogen as means for decarbonization, operation, and improve sustainability. As I told, hydrogen storage is a very crucial part. There are some solution. Efficient storage is crucial for widespread adaptation of hydrogen fuel given in low energy density. Various storage methods include compressed gas, liquid hydrogen, and chemical hydrogen storage. These are the different methods how we can make it as a compressed gas or liquid hydrogen and chemical hydrogen for storage person. Innovation in hydrogen storage technology are essential for enhancing safety and efficiency in distribution. Hydrogen can be used, as I told, it can be used for transportation, it can be used for heating appliances. Why it is used for heating applications? Most of the heating applications will produce carbon dioxide as byproduct. But by using hydrogen, it will be more eco-friendly. Hydrogen can be blended into natural gas for a residential and commercial heating system. It can also be used in dedicated hydrogen boiler, providing a clean heating alternative. This application supports decarbonization of heating sectors, which is significant contributor for emission. Here you can the slide diagram you can see how it can be used like zero carbon heating for homes. Hydrogen in maritime transport. Here the advantage is in fuels. No, this fuels byproduct will be going to the sea and it is polluting the water. This can be reduced by using hydrogen fuel cells. That's why it is used in maritime transportation. Hydrogen fuel cells are being explored as a sustainable power source for ship and ferries. The maritime industry faces stringent emission regulations, making hydrogen a viable solution for compliance. Earlier adopters are already tested hydrogen-powered vessels to demonstrate feasibility and efficiency. Hydrogen, here we can avoid air pollution by using hydrogen in aviation. Hydrogen has potential for revolutionize the aviation sector by powering aircraft with zero emission energy. Several companies are developing hydrogen-powered aircraft and exploring hybrid solution. The transition to hydrogen in aviation could significantly lower the carbon footprint in air travel. This I already covered, storage method. I'll skip this slide. Hydrogen infrastructure development. Actually, government has having supporting many companies by giving subsidies and all for for this establishing the infrastructure. This slide will show actually just to show that hydrogen infrastructure. Developing hydrogen infrastructure is essential for supporting the hydrogen economy. Investments in hydrogen production, storage, and distribution network are critical for growth. Collaboration effect between governments, industries, and research institutes are needed to overcome infrastructure challenge. Global hydrogen. Here you can see different countries uh, adopting hydrogen strategies like Japan, Germany. How much their organization, different organization. Uh, just for your reference only, need not have to go. Next, hydrogen. I think hydrogen. I have gone to hydrogen economy. Next, I'll see. Now, you know how hydrogen is generated, and using this, using hydrogen, how fuel cells works. I will explain you next. Is it clear for hydrogen? Hello.
Yes, ma'am.
Hydrogen economy. Any doubts in that? Hydrogen generation.
No, ma'am, you can proceed.
Yeah, I can go to the fuel cells then. No?
Sure, sure.
Yeah, till now we have seen how hydrogen is generated, its use, where it is used, and which other countries are using. Next, we'll see about what is a fuel cell. What is a fuel cell then? Fuel cell is an electrochemical device that combines hydrogen and oxygen to produce electricity with water and heat as its byproduct. Like of the more working on that, I will explain. The overall reaction or oxidation of fuel. Sorry, the slide has gone. Here, hydrogen and oxygen will combine to give byproduct is water, and it will generate electricity, which is shown in the figure. Why is fuel cell technology important? Since conservation of fuel to energy takes place via an electrochemical process, no combustion. It is a clean, quiet, and highly efficient process, 2 to 3 times more efficient than fuel burning. Next, I will just give an introduction to fuel cell and how it will work also. Fuel cells are devices that converts chemical energy from hydrogen and oxygen directly into electricity. They operate through an electrochemical reaction, providing a clean and efficient energy source. Fuel cells can be used in various applications, including vehicles, stationary power generation, and portable devices. How fuel cells work? A fuel cell consists of an anode and a cathode and electrolyte that facilitates ion exchange. Hydrogen is fed into the anode, where it is split into proton and neutron. As you can see in the diagram, electrons is a negative and protons are positive one. Protons moves through the electrolyte while electrons create an electric current before recombining with oxygen at the cathode. See, the electrons before recombining with the proton, it will generate electric power. This is how power is generated in the fuel cell. Any doubt?
No, ma'am.
Okay. What are the different types of fuel cells? Actually, depending on the membrane and substance used, it will differ. There are several types of fuel cells, including proton exchange membrane fuel cells and solid oxide fuel cells. I will list out the next. Proton exchange membrane fuel cells are widely used in transportation due to their quick startup and efficiency. And solid oxide fuel cells operate at high temperature and are suitable for stationary power generation, offering high efficiency. These are the different companies who are generating, who are producing fuel cells. Like I will list out which technology they are using, also and which temperature. This slide. In the slide I have listed out. You can go through that. What are the different types of fuel cells and what are the electrolytes? What is their gas at anode, cathode, and the water temperature and the efficiency is also listed out in table. These are different. There are 6 types of fuel cells: proton exchange membrane, alkaline, direct methanol, phosphoric acid, molten carbonate fuel cells, and solid oxide fuel cells. In proton exchange membrane, solid polymer membrane is used as electrolyte. Anode gas is hydrogen, and cathode gas is atmosphere oxygen. And temperature required is 75 degrees. Efficiency is 35 to 60%. And in alkaline fuel cells, electrolyte is potassium hydroxide, anode gas is hydrogen, and cathode gas is pure oxygen. Temperature is less than 80 degrees. Efficiency is 50 to 70%. In direct methanol, solid polymer membrane is the electrolyte, anode gas is methanol, and cathode is atmosphere oxygen. Temperature 75, 35 to 40%. Phosphoric acid, phosphorus is at electrolyte. Anode gas is hydrogen, cathode gas is oxygen. Temperature is 210 and efficiency is 35 to 50%. And molten carbonate fuel cell, alkaline carbonate is electrolyte, anode gas is hydrogen, cathode gas is atmospheric oxygen, and temperature is 650 degrees. Efficiency is 40 to 55%. Solid oxide, ceramic oxide is electrolyte, anode gas hydrogen, cathode gas oxygen. Temperature is very high in this, 800 to 1000, and efficiency is 45 to 60%. It's a brief about, more clear about how the fuel cell. It operates similar to a battery, but it does not run down or does it require recharging. As long as fuel is supplied, a fuel cell will provide both energy and heat. A fuel cell consists of two catalyst-coated electrodes surrounded by electrolyte. One electrode is an anode and another is cathode. Process begins when hydrogen molecules enters the anode. The catalyst coating separate hydrogen negatively charged electrons from positively charged proton. Do you know what is a catalyst used in this one? Mainly platinum is used as catalyst at anode. The electrolyte allows the proton to pass through to the cathode, but not the electrons. Instead, the electrons are directly passed to the external circuit to generate electricity. While the electrons pass through the external circuit, oxygen pass through the cathode. There the oxygen and proton combines with the electrons after they have passed through the external circuit. When the oxygen and proton combines with the electron, it produces water and heat. Water and heat is the byproduct of fuel cells, actually. Any doubt about this? This is polymer electrolyte membrane method, fuel cell. Sorry, proton exchange. The proton exchange membrane. Proton exchange membrane is a leading cell types of passenger car application. Uses polymer membrane as electrolyte. Operates at relatively low temperature, about 175 degrees. Sensitive to fuel impurity. You can see here hydrogen electrons passing, protons are exchanged to the anode through polymembrane. Electrons are passed, which is generating electricity, and here the hydrogen is combined with the cathode oxygen to produce water, that is a byproduct. Water and heat out. This is all the same thing, what I explained now, no? The same thing is here. This phosphoric acid, you are seeing same method. This is the most commercial developed fuel cell. It generates electricity at more than 40% efficiency. Uses liquid phosphoric acid as electrolyte and operate at about 450 degree Fahrenheit. One main advantage is that it can use impure hydrogen as fuel. Solid oxide uses a hard, non-porous ceramic compound as electrolyte. Can reach 60% power generating efficiency, operate at extremely high temperature, uses mainly for large high power applications such as industrial generation stations, mainly because it requires such high temperature. Alkaline. Alkaline fuels is used mainly for military and space program. Can recharge 70% of power generating efficiency, but considered too costly for transportation application. It is used in Apollo space aircraft to produce electricity and drinking water. In Apollo spacecraft, they are using this method, producing electricity and even drinking water also. But byproduct, you all know, is fuel cell. The byproduct is H2O. Uses a solution of potassium hydroxide in water as an electrolyte and operate at 75 to 160 degrees. Can use a variety of non-precious material as catalyst at the anode and cathode. This is now in catalyst. Catalyst is non-precious metal actually in this. The other one, PEM, it is platinum is used actually. Alkaline, it is the diagram. Here OH minus is the electrolyte. Potassium hydroxide is used as electrolyte. That's OH minus is the electrolyte used here. Regenerative fuel cells currently researched by NASA. This is about this regenerative fuel cell. This type of fuel cell involves a closed loop form of power generation. Uses solar energy to separate water into hydrogen and oxygen. Hydrogen and oxygen fed into fuel cells generating electricity, heat and water. The water byproduct is then recirculated back to the solar power electrolysis begins the process again. Sorry. Any questions till now? Okay. Next, we'll see what are the advantages of fuel cells. Fuel cells produce electricity with zero emission, contributing to cleaner air and reduce carbon footprint. They offer high efficiency compared to traditional combustion engines, converting more energy into usable power. Fuel cells can operate quietly, make them suitable for residential and urban applications. Challenges facing fuel cells. High cost of fuel cells and hydrogen production remains a significant barrier to widespread adoption. As I told before also, hydrogen production is very costly process. The infrastructure for hydrogen production is very high. The infrastructure for hydrogen distribution and refueling is currently limited in many regions. Public awareness and acceptance of fuel cell technology and hydrogen as a fuel source need improvement. I'll list out some uses of fuel cells. First, in transportation, hydrogen fuel cells are being used in various transportation modes, including cars, buses, and trains. They offer a clean alternative to fossil fuels, reducing greenhouse gas emission in transport sectors. Major automotive manufacturers are investing in hydrogen fuel cell technology for future vehicle modes. Storage and transportation. This already I have given hydrogen storage. I'll skip this side. Now some case study. Germany. Actually, Germany is a leader in hydrogen technology and has set very good target and set a very good target for hydrogen production. The country is investing heavily in green hydrogen project to decarbonize its economy. Germany's approach serves as a model for other nations looking to adopt hydrogen solution. Next is Japan. Japan has been proactive in developing a hydrogen economy, focusing on technology and infrastructure. The country aims to use hydrogen for energy security and to reduce reliance on fossil fuels. Japan's commitment to hydrogen is evident in its investment in fuel cell technology and vehicle. Countries like Japan and Germany are leading in hydrogen adaptation and infrastructure. You can see in the PPT that different countries who are using hydrogen and various companies also. It is mentioned in the PPT throughout the world who are using like USA, Japan. It is showed in the. It is just for case study. Government policies and initiative. Actually, government is ready to give subsidy for hydrogen production. Government is also supporting in many ways. Many countries are implementing hydrogen strategies to promote clean energy. Investment in research and developments are crucial for advancing hydrogen technology. Incentives and subsidies are being introduced to lower the cost of hydrogen production. See, Poland, you can see they are generating around 2 gigawatt. Portuguese 2.25 gigawatts. It is listed out. How much is presently? How much? Around 40 gigawatts of power is generated using hydrogen overall the world. This is almost same. I'll skip this slide. Yeah, this is our cube. What is a initiative for our government? Here, our union cabinet approves for production of natural green hydrogen. They're expecting by 2030 at least mm, 5 million metric ton green hydrogen annual production by 2030. Our union cabinet has already given approval for that. For that, we need 60 to 100 gigawatt electrolyzer capacity and 125 gigawatt renewable sources. In this, they are planning at least investment of 8 lakhs crores. They are planning to investment of 8 lakhs, but they are already approved for uh, this many crores, 19,000, around 90,000 crores. In this advantages, we can stop importing around 1 lakh crore of fossil fuels. We can stop that importing, and we can reduce that around 15 million metric tons of carbon dioxide emission, which is happening now. We can reduce that, and we can. The government is thinking they will get around 6 lakh job opportunities also. That's why cabinet has approved for this, and by 2030 maybe this will come. This plant will be ready. This is a slide showing that around that. Government worldwide are implementing policies and incentive to promote hydrogen technology and infrastructure development. International collaborations are being formed to establish standards and regulations and safety protocols for hydrogen users. For anything, any development, we need an establish a standard. That standard they are trying to actually develop. Supportive policies can accelerate investment and innovation in hydrogen production and fuel cell technology. This is repetition slide. Actually, as I told, we need renewable energy for hydrogen generation. We'll see what is the role of renewable energy. Renewable energy sources are essential for producing hydrogen, green hydrogen sustainably. Wind, solar, hydroelectric power can be used to generate electricity for electrolysis. Actually, there is a mutual relationship between these two. Renewable and hydrogen can enhance energy release. And whatever generated, we can generate hydrogen using renewable source, and generated hydrogen can be used again for generation of hydrogen. That's why there is a synergetic relationship that is mentioned. You can see in the slide, around $38 is required for cost for megawatt per hour for wind. You can see all are really $64 is cost for per million watt hour. And these all how much cost? By using hydrogen, this cost can reduce. This slide is repeated one. This is also repeated slide. But now we'll see what are the challenges facing in fuel cell. The high cost of fuel cell system and hydrogen production remains a significant barrier to widespread adoption. Infrastructure for hydrogen distribution and refueling is still under development in many regions. Storage and transportation of hydrogen poses safety and logistics challenges that need to be addressed. That is not addressed till now. This slide, same thing is there in hydrogen also. Fuel cell for hydrogen generation, after that only we can generate fuel cells. This is an application, how fuel cells is used in transportation. You can see in the diagram. Here fuel cells is stacked and there is a hydrogen storage stack, and with that we are generating power. using in the power control unit. The automotive industry is investing in fuel cell technology to develop zero emission vehicle. Hydrogen fuel cell vehicle have longer ranges and faster refueling time compared to an electric vehicle. It need not be charged. Several manufacturers have introduced FCVs to market, signaling and a growing interest in this technology. Fuel cells and stationary power. Fuel cells can provide reliable and uninterrupted power for commercial and industrial facilities. They can be used in combined heat and power system, improving your overall energy efficiency. Deployment of fuel cells for grid supports can enhance resilience against outages. Environmental impact of fuel cells. Fuel cells produce only water and heat as byproduct, making them an eco-friendly energy source. They contribute to reduce air pollution and lower greenhouse gases emission compared to conventional fossil fuels. The widespread adoption of fuel cells can play a significant role in combating climatic change. Case study. This case studies are emerging worldwide, showcasing successful fuel cells implementation in various sectors. For instance, Japan has made significant investment in hydrogen technology, integrating it into their energy strategies. Various cities are adopting fuel cells buses to reduce urban air pollution and promote sustainable transportations. Comparison with other sources, like fuel cell will be always compared with a battery. Fuel cells are often compared to battery and traditional combustion engines in terms of efficiency and emission. While batteries store energy, fuel cell generates it continuously as long as fuel is supplied. This distinction gives fuel cells advantage in certain applications, especially for long range transportations. Economic potential of fuel cells. Actually, this slide, yeah. The fuel cell market is expected to grow significantly as demand for clean energy solution increases. Investment in fuel cell technology can create job and stimulate economic growth in energy sector. Collaboration between industries and academies are essential for driving innovation and market readiness. I can see international collaboration. Global collaboration is crucial for advancing fuel cell technology and hydrogen. International partnership can facilitate knowledge sharing and research advancement. Initiatives like Hydrogen Council brings together stakeholders from various sectors to promote hydrogen adoption. You can see who the key players of fuel cell industries, how much shares they have. These are the different companies who are using fuel cells, hydrogen fuel cells. Volkswagen is using, they're having a share of 16%. Toyota is having a share of 12%. These are the different industries who are having share with the hydrogen, share for hydrogen. Major automotive infrastructure such as Toyota, Hyundai are leading the way in fuel cells vehicle development. Companies like Ballard Power System and Plug Power focuses on fuel cell technology for various applications. Startups are also emerging, driving innovations and competition in fuel cell market. Yeah. Here, as a conclusion, I can say that fuel cells represent a promising technology for sustainable energy future. With the continued investment and innovation, they can play a significant role in reducing our reliance on fossil fuels, like petroleum products and all. The transition to hydrogen economy is underway. The fuel cells will be at its forefront. With this, I'll conclude my session. Hello, ma'am. Anyone has any doubt about it? or any clarification is required on this?
No, ma'am. No.
Yeah.
Excuse me?
Um, Thank you, Jyotsna madam, for your valuable information. Thanks a lot. The participant will give you 5 minutes break. We'll start the next session after 5 minutes.
Yeah, any doubts or clarification required?
Participant, anyone has doubts, you can ask the question.
Pardon, it's not audible. Can I end the
Okay,
session?
thank you, ma'am.
Thank you.
Thanks a lot.
Thank you, ma'am. Thank you. Thank you, one and all. I'll end my section with this. Like,
Hello, break for 5 minutes, and after that, we'll start the next section.
मैसेज देते मैं आता मैसेज
Now, next speaker, Mrs. Hajira Fatima. She is currently working as an assistant professor Maulana Azad National Urdu University, Polytechnic, Hyderabad. And she did BTech from MJCET and MTech from Osmania University in Signal and Systems. More than 20 years experience in the field of electronics and communication engineering. She has been the resource person in many workshop and faculty development program. Now, madam, please start your session.
Thank you, Zirid ma'am, for your nice introduction. Very good afternoon to all the participants. I'm Hajira Fatima. Currently, I'm working as an assistant professor with Maulana Azad National Urdu University, located at Hyderabad. I have chosen today's topic for the session as the integration of renewable energy into the Indian grid. Like through this 5 days of your faculty development program, I hope you might have gone through the various.
Excuse me, madam.
Yes.
Full screen slides.
Yeah, sure. I'll be doing that. So in this 5 days of this faculty development program, you might have gone, come across the various renewable energy resources, like what are the advantages with different resources and what are the challenges, the difficulties with the different types of renewable energy sources we are facing right now. And you might have also seen what are the different ways to improvise this generation of the power by making use of this renewable energy sources by using some hybrid techniques as well. So the topic which I have chosen is, we have seen like we have different types of renewable energy resources, but what like ultimately we need to grid this power generated by these different renewable energy resources into our Indian grid. So first we should understand like how our Indian grid works, what are its demands, when do we have high demand, at what time of a day we have a high demand, at what time of a day we have a low peaks, and so on. So first we'll see like how this renewable energy systems, the different resources are being utilized in India, and to what extent we are able to generate the power by making use of renewables in India, and how these power generated by these resources is being integrated into our own Indian grid. Just let me to share my presentation.
Ma'am, we cannot share.
Yeah, I have not presented it. I have not shared it, sir. Just give me a
Okay.
second. I hope the screen is the
Yes, ma'am.
presentation.
Yes, ma'am. We can see the presentation on full screen.
So now, let us start off with the So the agenda, the topics which I'm going to cover in my presentation are like these 5 things which we'll be discussing about what is renewable energy and what are the unique characteristics of renewable energy, and why it has become so unique and so predominant to make use of it. And what's the so uniqueness of the renewable energy that we are discussing about the integration of these renewable energy sources to a Indian grid. Like from a long time, we are making use of hydropower, thermal power, but we never discussed integrating of these thermal energy power generated to our Indian grid, or hydropower generated, integrating it to a Indian grid. But there is some uniqueness with this renewable energy sources power generation, because of which it's very important for us to know how it's being integrated to our Indian grid. And in what way this Indian operating grid is unique, and is it ready to accept the integration of renewable energy, and what are the real challenges in the integration, and what are the options available? If there are challenges, then what are the options available, and what's the future, and what's the future that is awaiting for the in this power sector, which can pave way to for budding engineers and research scholars to work on these areas, like prospective areas, which are a need for the country now. Now, renewable energy has become very important topic in recent years. Mostly, it's like after post Paris Climate Summit, as per the United Nations Framework for Climate Conservation Change (UNFCCC), India has committed some goals, of which the most important was to have a 30% of installed capacity of energy generation based on non-fossil fuels generation of the power. India is so comfortable till now from the point of time with the fossil fuel based energy generation, because around 80% of the energy generation was through these thermal based systems, and we have got so many number of advancements, and efficiencies have been consistently improved, and the grid was also so comfortable with this conventional methods of power generation. But post 2016, there has been so much of impetus on the development of renewable energy, owing to the environmental concerns and for having a sustainable development coupled with energy security. And across the globe, there are too much of efforts. Few countries have crossed great achievements, while European countries have done well, quite well. But India by that time was so primitive, but now it's fast. It's the fastest developing in terms of renewable energy, and it has aligned itself towards the global pathway. It has set a target. India has set a target of 450 gigawatts. In terms of megawatts, it is 4 lakhs 50,000 megawatts of renewable energy capacity to be achieved by the end of by the end of the year 2030. For your understanding, the present day, the entire Indian grid installed capacity is only 3 lakh 80,000. But in the next few years, by the end of 2030, we are aiming to establish renewable energy sources capacity for 4 lakh 50,000 megawatts of energy. So, when such large scale penetration of a unique kind of energy into the grid requires a lot of innovations, some disruptive, non conventional changes are expected. But why? Because of the nature of renewable energy sources, which don't act as a base load as of now. But it is expected that they are going to give energy as base load, but those are future. Those are in the future. This penetration has got a future. You have got a target which requires detailed analysis, and that detailed analysis is going to come in the coming part of our presentation. Renewable energy. By the term, what is renewable energy? Can anyone from the participants, can I have the answer from anyone of the participants, like what is meant by renewable energy? We can define two terms related to specifically related to renewable energy. It can be defined like as It is a clean form of energy. And the second thing we can say, it is replenishable. You don't annihilate something, you don't exhaust something, which is a natural source which comes again and again. Upon its usage also, comes again and again. It won't replenish. So clean and replenishable, non-depletable. These are like a 2 or 3 characteristics which speaks about renewable energy sources. While all other conventional sources are depleting, maybe your fossil fuels, it's highly depleting. Maybe your nuclear, it's depleting. While these sources of renewable energy don't deplete, some sources of renewable energy are like hydropower, wind, solar, biomass, geothermal, and ocean energy. We have got large number of resources of renewable energy. But coming to Indian context, we don't have large hydropower plants, are not bought under renewable energy sources in India. They are a separate category, like small hydro plants less than 25 megawatts capacity, which are being taken as renewable energy sources. Coming to Indian context, wind and solar are predominant. These two energy sources are predominant as coming to India. And in coming to this, coming to wind, India is bestowed with wind-rich sites, so we can make a maximum utilization of this one. We have got some developed wind generation sources as well in India. And coming to solar, India being a tropical country has got good potential for the development of solar energy. And we still have good amount of solar capacity installed as well as of now in India. Now coming to biomass agricultural land has got a good source of biomass. Now next is geothermal and ocean energy. They don't fare well in the Indian context, but those are available in other nations where they have got the good potential. They are making other countries. When we have a good potential with the what do you call it, as a geothermal and ocean energies, they are doing quite well in those countries. But coming to Indian context, we can't make much use of it. These are the some sources of renewable energy, in particularly in India. With respect to Indian context, wind and solar are gaining utmost importance, and or of a get for us, it's of important uh, for us to concentrate more on these energies because they have high potential with respect to Indian context. Now we have seen like what are the different energy resources available, and coming to Indian context, like wind and solar are more predominant. Like we have high potential with these energy resources. But what are the challenges? Like when we are planning to use them, like what are the challenges? Renewable energy sources has got like a few characteristics we could say are which pose as challenges to the operating grid right now. See, we know that the renewable energy is clean, it is non-depletable, but the challenges are it is intermittent. By intermittent, we mean it is not continuous. It operates for a specific period of time in a day, maybe for 8 hours in some locations, or which has got some solar radiation, maybe of 10 hours. So this is going to pose a big challenge for us when we are making use of renewable energy, solar renewable energy. And coming to variability, solar comes with that characteristic, like we could say, variability. As far as variability is concerned, this particular source of renewable energy comes for a season. In a particular season, we'll have good source of solar energy. In particular season, we may not be able to have that much of good quantity, good solar energy. So, like let us say in June, July, and August, normally we get more wind generation in these months. So when we discuss with respect to the solar and wind, The main challenge is intermittency. They are not continuous. They're available only for a very specific period of a year, and there's a variability. If you consider a particular day, we can't expect the solar energy to be same throughout the day, or the wind speed to be same throughout the day. There's a lot of variability in these two renewable energies. Okay, and now the next one is uncertainty. As a matter of fact, we don't have a control over these natural parameters, and they are hard to forecast. Either it's be the sunlight or the sun's glow, sunlight, clouds passage, or wind speed. We don't have a control over it, and it is hard to forecast as well. It is tied to forecasting, or it is tied to meteorological forecast, we could say. It does not support the grid security. Say, for example, grid at times requires a little bit less power, or at times it requires some more power because of some demand. It's being happen The demand which is being happening at the grid. So this renewable energy sources will not support the grid to that extent. So there's a lot of uncertainty with respect to this type of renewable energy sources. Now, the next one is locational dependence. Though India being a tropical country, we have a lot of solar potential, and which is rich in deserts, and wind potential is rich in offshore locations. But the load centers are not nearer to the deserts. The load centers, the way we need more power requirement, the areas where we have more power requirement will be nearer to the, are in the urbanized areas will have more power requirement. But the areas where we have a high potential of this solar power generation or wind power generation is towards the sea offshores or in the deserts. So there's a lot of difference, locational difference. We have a demand at one place, and we have a power generation unit at other place. So they need to be the power generated at a seashore, like in a desert, where it is rich with the solar potential. It need to be transmitted to the demand area, urbanized areas where the demand of the power is more. So the load centers are located somewhere nearer. Load centers should be located somewhere nearer to the urbanized areas or urbanized locations, or it need to be transmitted. Here, generation is at one point and necessity is at another point. So it need to be coop up. Like some alternatives need to be taken care to come up with a solution to this sort of a challenge. We can either transfer the generated power, or some alternative need to be taken care of. The next is non-synchronous technology. Renewable energy sources are connected to the grid, or we could say the consumer, through power electronics rather than any rotating equipment, we could say. In solar energy, photovoltaics receive sunlight and convert this sunlight into electricity. Well, this electricity is it in DC form, and your grid is on AC. So this DC is to be converted into AC in an inverter based on some power electronics. Similarly, wind turbines are operating on variable speeds. This variable speed AC need to be converted to DC, and this DC generator need to be converted back to some AC using some power electronics and is pumped into the grid because of some quality issues. In thermal generations or the traditional techniques, they respond to the grid requirements. We call it as grid services. But our renewable energy resources won't support this one. They don't respond to the grid services. At some point of time, if we at some point of a time in a day when we need more power, the power demand is more. So we can't expect a solar power plant to generate more power at the end of the day, in the evening, or if we have a high power demand at that time. So in that way, it won't support the grids, grid services, because the few parameters of this renewable energy are not in our control. So it won't control the grid the way it is expected to do. No, neither the solar nor the wind sources can respond the grid services. It is because it is certainly out of our control, and it depends purely on nature. So these are the few challenges. Now let us see this wind generation chart month-wise. We can see that the wind power generated by this wind using wind is more particularly in the months of you could say June, July, August, and when we see for April, the power generation is very quite low, and on the other side in the October, November, December, and so on, when we see the power generated by using these wind turbines is quite low. In the months from you could say June, July, August, September, we could have a good quantity of power generated by wind turbines. So it is seasonal based. In few months only, we can expect good power generation using this wind turbines, using this wind source. But we have the requirement 24 hours a day, 365 days, and 24 hours a day. So they pose a challenge over here now. Next, coming to this solar generation chart, we can make out that the solar generation, like the solar plant will start generating energy somewhere around the 6 o'clock. It's starting at the peak at 12 noon. We have a peak of the solar power generation, and as the day passes on, till 2 or 3 o'clock, we'll have a good amount of power generated by this source. But as it comes to around 6 p.m. Evening, 6 o'clock, the peak comes down. Will hardly have and then it will become very low. We'll have a maximum per generation using this solar energy in from, we could say, from 12 to 2 o'clock, 12 to 3 o'clock. And the other parts of the day, it is not that high enough. But in this period also, we can make out one more thing, that we have a peak of the power generation by the solar energy is maximum at around 12 o'clock peak. But and it is considerably good enough from morning 10 a.m. to, we could say, evening 4 p.m. But though in this time period also it is not flat, we can make out that it's a peak, but it's not a flat to pertaining to the amount of the power generated. And it's now we just had it's in the form of a peak. This may be due to some, we could say, some climatic changes could be there, some wind changes, or cloud movements could be there, or dust, or a lot of issues will be there. This is the profile of the power generated by a solar resource. And here as well, we don't have the control over these different parameters which are affecting the power generation in the daytime as well. Now it's coming to the uncertainty, as just now we have discussed, like whether it's related to wind power, it's related to solar power. There are few parameters which are not in our hand, so there's a lot of uncertainty. Solar power depends on a number of factors, like lot many factors comes into the role on its generation, like characteristics, we could say. It depends upon the speed of wind speed, it depends upon the humidity, rain, ambient temperature, and the dust concentration, and so on. And these parameters are not in our control. That was a big challenge for us. So we have a kind of uncertainty about the per generation with respect to these parameters. And at no time we can tell that we can't say that we by using a wind turbine, wind power generation plant, by this time I can generate this many megawatts of power. Due to any reason, due to any parameter, the expected, like if we could say I can generate a 10 megawatts of power, due to any of these parameters, we may not be able to generate that much power. Though there's no such certainty is there that we could say that by guaranteedly we will be generating this much of power by this time of a day, by this time. By you, when we make use of this wind power plants or solar power plants. Mm, and which is but which is very much required for a stable operating grid certainty, like what amount of power will be generated by a power plant, or will be available with a grid, operating grid by and so time. It is a very predominant factor with respect to the operating grid, for the with respect to the stability of the operating grid. The same with the solar power as well. The generation of the solar power as well has come up with so many uncertainties, like wind speed, the cloud movement, the humidity, the dust concentration, or the rain. It also affects the amount of the power being generated by a solar plant. This is a global solar atlas. It is locational dependent. As we know that the solar energy is locational dependent, it is not same everywhere. It varies from place to place, location to location. Even in India, though it is a tropical country, we are in a mid generation range, and can we say a 16 lakh units per 1 megawatt per year on an average, we can say it can be generated by using this solar power plant. And some locations in Rajasthan, we could say desert, we can have, they can offer around 20 lakh units as well. It depends upon the irradiation factors. So establishing a unit at such places is more economically viable. And at places where it is less than 16 lakh units, will not be a viable option because it may affect the economics of the plant. So, so the plants based on solar, if established at higher potential zones, you'll have more economics. Will be good enough for the plants. So we should first locate the high potential areas and need to establish the power plants in those areas. The same thing goes with the wind potential as well. We need to first, the wind potential is different across the globe. In state of Tamil Nadu, we have got certain locations where wind potential is very good, so we can have wind generation per plant in such places where the average wind speed is more than at least by 6.5 meters per second. So establishing a wind power plant at places where the wind potential is more will be a good idea and an economical idea as well. Non-synchronous power generation. Generally, we'll say that the rotating equipment requires higher maintenance cost. When we go for a solar power plant, there'll be no rotating equipment, though the maintenance cost of it is also but still high. And a lot of power electronics is required to convert the DC power generated with the solar power plant into the AC and integrate it into the engine grid, operating grid. And both the solar power plant and as well as the wind power plant are non-responsive to the grid requirements. At any time, the operating grid, if it requires more, if there is a high demand, then this power plants will not be able to cater to the need. Or when there is when the need is less, when the more power requirement is not there, we can't flux the power generated by these resources, either the solar resource or the wind resource. So it's quite non-responsive, we could say, to the grid requirements. So till now we have seen like the renewable energy resources, which are predominantly which type of resources have high potential with respect to the Indian context, and what are the challenges they are posing: intermittency, uncertainty, non-responsiveness, and so on. So now we'll see like how Indian grid is working. What are the unique characteristics of our Indian grid? Then we'll see how to integrate these renewable energy sources, which are predominant in India, like solar energy and wind energy, into our unique grid of Indian operating grid. When we come to this Indian grid, it's a bit unique when compared to the operating grid of what do you say, the other countries. It's unique in a way that it has two peaks and two lows, and on a same day, your need of your demand power demand of the power is not flat. At certain point of a time in a day, the demand is very high, and at another point of a day the demand is quite low. So our Indian operating grid is quite unique with two peaks and two lows. On a particular day, this is a chart showing the demand met by the power demand met on that particular day. We can make out from this chart that at around what you could say, at around 9 o'clock, there's a peak power requirement around 180 gigawatts of power requirement is there. Again at morning 4 o'clock, there's a low. The demand is quite less, the power requirement is quite less. At 9 o'clock, the demand, 9 or 10 o'clock, we could say there is a very high demand of power. Once again, when it comes to 3 and 4 o'clock, the demand is it's coming little bit down. Once again, at around 6 and 7 o'clock, there's one more peak. The demand of power is still increasing. So this is a chart of a particular day to show how the power demand, the requirement of power in the Indian grid varies. It is not at all flat. During some specific time periods, there is a lot of demand, there's more demand, and at some other point of a time, the demand is less. So we need to cater the power generation techniques and the power which need to be generated in such a way that it should cater the need of this Indian grid, operating grid. And we are much aware that now it's not a flat grid. When we come to this source-wise generation, we can make out that we can see that we have different sources of generation, sources of power generation to meet the demand in the Indian operating grid. We are using thermal, we are using hydro, we are using nuclear, we are using wind, we are as well as using solar power plants, energy generation systems. So from this graphs, we can make out that we can see the solar graph, this yellow colored graph. It's again in the form of a peak. The maximum power being generated at at a specific time of a day in the afternoon, from 12 to 2 or 3 o'clock. A maximum power is being generated by using a solar energy, and in the other parts of the day, the morning, early morning, or coming to the late evening, the power generated by solar energy, we could say it's nil, it's going off. And when we come to the thermal energy, we can say this graph, the power generated by this thermal energy is mainly catering the need of Indian grid. It is a main source. We could say that 80% of the power is being generated by using this thermal energy sources, where it's catering the need more appropriately. And this blue colored one graph is of hydro power generation. At about 10 to 15%, it's catering the need of our power requirement, we could say. And all other different energy resources are quite at the power generation, they are of, giving very less amount of power. The main energy source which is predominant now as well is the thermal energy source. With the respect to this, with respect to the generation of the power. Now this is the source-wise contribution. We can say that once again we can see this coming to the contribution of the power generated by different types of this resources. So we can say this brown colored area is the power generated by mainly the thermal sources. So thermal and energy source is catering a maximum of the need of the power in India till now as well. And as a question, we have a hydro power, and we can see this yellow part. This blue colored area is the power generated by the using hydro sources and hydropower plants, and this yellow colored part we could see is the power generated by using the solar power plants, and the other are the wind and the other resources. So as of now, this is the source-wise different source-wise contribution of the energy catering to the need of our power requirement in India. And this is the demand on one particular day. This is the demand position. It shows us that at a time of the day, at early morning 3:35, the demand is we could say 1,22,000 megawatts. And by morning 9:48 at around 10 o'clock, we could see that the demand is going high by 1,82,888. So roughly there is a difference in the demand by 60,000 megawatts, and at 11:20 it is 1,80,000, and so on. At different instance of time in a day, the demand of the power is being varying, and on this particular day it's been observed that there is a variation in the demand by about 60 megawatts. It's a very high variation, that the power variation of 60 megawatts in a particular day at two different time slots is a very big variation we could see. And it is very unique as compared to the other countries. In most of the other countries, this much of high variation in the power requirement at different instance of time will not be there. Most of the other countries will have a little bit, not flat, but little bit a sort of a flat curve only of the power requirement. But coming to the Indian grid, we'll have many peaks. Like we could say that at least we have two peaks and two lows of the power requirement in our grid. And this is the energy statistics on that particular day, when there was a power variation of 60,000 megawatts of power. These are the different sources through which the energy is being generated. Coal and lignite stands for 75% of the energy on that particular day was being generated by using coal and lignite, and hydro has served 7.27%, and coming to renewable energy sources, they served 10.48% on that particular day, we could say. So we could say that till this point also, the thermal fossil fuels are playing a major role in generating a lot of power and meeting catering to the needs of the Indian operating grid. And the same thing on one more particular day, as randomly when it's been selected, we could see this is a plot, a graph showing the power requirement in gigawatts on a particular day from at a different time instance. Once again, we can record that at early in the morning, there's a low in the power requirement. Much power is not required, and again at around 9 to 10 o'clock, we have a peak. We have a high power requirement at around 9 to 10 o'clock. And this curve, when we compare to the other curve, which I have shown to you a bit earlier, this particular curve, when we compare this curve on one particular day and this one on another particular day, we could see that though the peak is not that much, but still we could say that this is not a flat curve. We can't say still it's a flat. Still there's some sort of a peaks and lows are there in the power requirement. And in if we see the demand position on this particular day, we could see that at early in the morning at 3:35, the demand in power is 1,52,000 megawatts, and when we see it at 10:20 a.m., we can see that the power requirement is 1,85,000. So there's a variation of about maximum variation is of about 32,792 megawatts. So on that particular day, when we have selected, there was a variation of 60 megawatts. On this particular day, on some randomly chosen particular day, the variation in the power, the maximum variation, we could see here the difference in the variation. Maximum variation is 32 megawatts of power. So on a typical, we could say, typically we can approximate in this way that we'll have a maximum variation of around 30 megawatts in the power requirement on daily basis as compared to the demand position in the Indian grid. Now this is a mix of how this various sources been catering to the need of the Indian grid. That is what being emphasized over here. And uh, uh, by from this chart we can say that this pink colored bars show that in different months energy being generated by the conventional sources, thermal or hydropower sources, and this blue colored one shows the energy being generated by all renewable energy sources. So when we can make out from this graph that still the energy being generated by renewable sources is about 10 to 12% only when compared to the conventional energy sources generating power in meeting the power requirement, the demand. A lot more development still need to be done. Now this is the projection. What is the projection? All these renewable energy systems are perfectly integrated. Then we could see that what's the projection with these different renewable energies sources, which is being projected over here. It's been projected in this way that by 2030, India would be able to generate a maximum of 435 gigawatts of power by using these renewable energy sources. So it will be approximately 53% of the power requirement by that by the end of the year 2030, and by 2040 India is expected to generate nearly 597 gigawatts of power by using only renewable energy sources. This is a projection, in this way. And it's projected in this way that India is going to cater 50% of the power requirement, the demand in the power, by making use of only renewable energy sources by 2040, and 25% by the end of 2030.
Okay.
Any doubt? Kindly participants, kindly please you mute your speakers. So this is renewable energy generation with respect to the Indian context, how it's being generated with the different renewable energy sources. We can say that particularly solar, if we could say by 2030, we are expected to generate 280,000 of megawatts of 280,000 megawatts of power by 2030, and by 2040, 367 megawatts of power to be generated by using only solar power plant. And if we see wind energy, the power being generated by this wind renewable energy by 2030 is 1,40,000, and by the end of 2040 it is projected to be generating by 1,85,000. A particular a breakup of if a demand of 175 gigawatts is there, it is breakup in this way that solar is expected to generate 1 lakh megawatts of power, and wind energy is to be used to generate 60,000 megawatts of power, and by using hydro it's expected to generate 10,000 megawatts of power, and by making use of biomass 5,000 megawatts of power to be generated. Now, we have seen much about this. What are the challenges and with the renewable energy, and what are the challenges in like we have seen like how our Indian grid, what is the requirement of our Indian grid. Now we'll see what are the challenges in integrating these renewable energies resources to our Indian grid. What are the challenges on one hand, and what need to be achieved. Let us see like what are the challenges and how to overcome them. Issues. There's issues related to unpredictable generation. We can't predict, like we can't say by this day by 12 a.m. or 12 p.m. We will be able to generate these many megawatts or 10 megawatts of power or 100 megawatts power. It's highly unpredictable. We can guarantee that by making use of either the solar energy source or only the wind energy source, will be able to generate these margin of power by this time, because of the various unpredictable parameters which are not in our control. And and on the other side, incalculable demand. The demand, as we have seen in on two particular days, the graph of the power requirement on two particular days, we can make out that the demand is also not calculable. It is different at different instance of time. So this unpredictable and uncontrollable generation, by making use of these renewable energy resources, will pose a few challenges which we'll try to overcome. And so we'll try to smoothly integrate the renewable energy resources, power generated by the renewable energy and resources to our Indian grid, by overcoming these challenges and meeting the demand of the grid. Now, the major challenges, most of unmatched, the very first one is unmatched generation and demand. Here we can say that we have a demand of a high power demand will be at one instant of time. Like we could see that we have a high demand in power at 10 a.m. in the morning, but we'll by making use of solar energy, we'll get maximum power will be generated by in the noon by from 12 to 2 p.m. So there is some mismatch between the generation of the power and the demand. There's a demand at some other time and the power is being generated at some other time. If you make use of wind energy, we'll have more power generated by the wind energy at evening or late evening or night time. But we have the demand of power in the daytime, in the early in the morning, and at around 6 to 7 p.m. in the evening, we have peaks in the demand of the power. So somehow we need to try to see some means to match this requirements of demand and the generation by integrating these renewable energy sources to our grid. The next one is non-responsiveness. As we know that the renewable energy sources are nature dependent. We doesn't have much of a we doesn't have any control on these parameters. So this non-responsiveness is also a big challenge when we try to integrate this renewable energy sources to the operating grid. Actually, the way how the grid works is the power generation resource need to respond to the demand of the grid, which is very lacking in this renewable energy resources. And when there is more power demand, the sources the grid need to supply more power, or when the demand is less, then the grid should curtail the per generation. So that non-responsiveness is also a big challenge over here. Yeah, and another one is the next is a must-run status. There's a mandate from government of India that this particular two renewable energy resource power generation units like solar power generation and wind power generation units, the plants need to run. We can't curtail the power generation by either of these two power plants. In case it's at certain point of time in a day when the power requirement is less, we can't curtail the generation of the power by using either of these two renewable energy resources. And if we curtail it, then the economics will be hardly hit of the this power plants. So we won't do it, and it also poses a big challenge over here when we go for the integration of this solar and wind energy resources power units integration with our engine grid. The next one is cost perspective. Renewable energy projects are land incentive, intensive. There's a thumb rule actually that 1 megawatt of plant requires approximately 0.5 acres of land. So this is for our conventional power generated by conventional sources. This is the thumb rule that when we establish a plant with to generate a 1 megawatt, it needs approximately 0.5 acres of land. The similar thing, if you want to establish initially a 1 megawatt of solar plant, it requires 5 acres of land. So it's land intensive. When we go for this wind resource, when we go for wind power plant or solar power plant, we need a wider area. Land requirement will be very high. If we establish 100 megawatt of plant by making use of conventional thermal plant, conventional sources, then we need only 50 acres of land. And the same thing when we go for solar power plant to generate 100 megawatts, we may require around 500 acres of land. But still, with the development and advancements in the technology, the area requirement is coming down, but not much. But still, it is very high as compared to this conventional methods. We could say the thermal generation plants. So here also it's a very big challenge which we need to overcome when we are integrating this renewable energy sources with the Indian grid, wherein in terms of generation of power, while 1 megawatt thermal plant will generate, we could say 87 lakh units in a year, we could say. This is for approximately for a thermal plant. But the same thing when we go for a solar generation plant, it generate for 1 megawatt solar generation plant will generate approximately 16 lakh units only in a year. So coming to this generation of power also compared to this thermal the conventional power plants, we could say that we have a low capacity utilization factor when we are making use of this renewable energy sources. And the transmission cost per unit is also high when we make use of this renewable energy sources. So these are the challenges which we need to overcome to integrate these renewable energy sources to our Indian grid. So till now we have seen what are the challenges. Now we'll see what are the Just a minute. Now, till now, we have seen what are the challenges. Now, we'll see what are the options, like how to overcome those challenges and how to integrate these renewable energies to our operating grid. What are the options and that need to be developed, and what are the best practices which we need to implement, and what are the best practices like many other countries have already making much use of this renewable energy sources to generate power to a major extent. So we need to say like what are the best practices being implemented by the other countries as well. In Germany, on one particular day, it has catered to meet the total power requirement of that country by using only renewable energy sources. So, what are the techniques being followed? What are the best practices followed by other countries in meeting the demand power requirement by just only using renewable energy sources? We need to see what are the options available and how to develop. Those options to cater to the need of integration of this renewable energy sources to our what do you say Indian operating grid. So, what are the valuable integrating ways we can make use of? So, these are the four best options and are the ways which are globally followed for renewable energy integration. The best methods are a wider balancing area, mm, and the next one is the energy storage systems, and the third one is flexible systems, and the last one is forecasting and scheduling. This wider balancing area method is the most important over here in integration of renewable energies to the Indian operating grid. See, when we make use of renewable energy sources, we know we have intermittency. We know their how variability will be there with respect to many parameters. But still, we need to see like we need to widen the area. We know that the solar and the power generated by the solar energy will be more predominant, will have more power generation by making use of the solar energy from around 12 o'clock to 2 to 3 p.m. So we need to find out where are the areas where we need more power in this time slot. Like in one particular place, we have a high solar potential. We are generating power, making use of solar energy, and at other area and some other area, we have at that particular time period, if there is more demand in power in that period, we need to transmit the power from one area to the place where there is a requirement. In that way, we can make use of the power generated by these renewable energy sources in a more appropriate way by balancing the power requirement, the demand, and the generation. At one place, if the generation of the power is more, we need to find out at the same place where the requirement is more, and balancing in that way will be a very good practice. And yeah, it is also the very low cost method available for integration, and regionally we should be spread across. Originally, the grid system should be spread across a wider area. Indian grid is synchronous. We have like 5 grids in India. We have southern grid, we have northern grid, northeastern grid, and eastern grid and western grid. Let us suppose at a particular point of a time we have more power generation in southern grid, and there's a requirement in the northern grid. So the power generated in the southern grid by making use of renewable energy sources need to be transmitted to the area in the grid where the power requirement is more. Now, if it is synchronized in that way, the usage will also be more appropriate, and the grid will also be well maintained and stable. The next one is energy storage systems. If you could say that yeah, power is the wind in power generated by making use of wind energy at night time is more. Then we need to store how to make use of that power generated by wind energy. We need to make use of pumped storage. Basically, the pumped storage is used in hydro systems, but it is bit as it is hydro systems are related to agriculture. It is bit complicated, but this is also one of the option we could say. And the next one is battery energy storage systems. With some technological developments can be used to store the power which is generated. If the power is generated at a particular time when the demand is less, then that power need to be stored by making use of some batteries. But when we make use of some storage system, the cost of where will be presenting this levelized cost of energy storage per unit will be around 6 to 8 rupees. So the cost of storing energy will be more. So we need to see some ways, some technological developments in the energy storage systems to generate the power generated by these renewable energy sources at such time where much demand is not there into the by making use of energy storage systems and catering to the need when there is high demand. This is also one option. The next one is we could say is the flexible systems. Coming to demand and generation, both in the demand and generation, there should be a flexibility. In the demand, we should see that when the solar energy is at its peak, more power is being generated in the daytime from 12 to 3 o'clock or so. And then the option should be given to the consumers that with respect to the tariff, if we make use of the per in this particular period the tariff will be less, or in some particular when we have a high peak demand in power at that time if the tariff is high, not all we could say loads are critical. They can be some loads can be planned at different times of a day. No, not all will be critical enough. So if they are planned at a different time of a day when the requirement of power is less, then in that way as well, the demand can be optimized from the customer side as well by imposing various incentives, or we could say, or what we could say, by imposing different tariffs at different period of time in a day as well. And the same flexibility in the generation need also be to it need also be to used over here by ramping characteristics, by so using some methods to have flexibility with the power generation systems to be integrated into the grid. When we see this thermal generation systems, they are more flexible, and they are more flexible. They can more accommodate more easily with this grid. When the power requirement is more, we can increase the we can this power generation can be increased by using this thermal plant, flux the system to generate lesser power as per the demand. That need to be incorporated. Some ways need to be taken out to do the similar things with the solar and the renewable energy sources. The last method is here the forecasting and scheduling. We have the prediction, different prediction methods where we if we make use of accurate uh, methods to predict, to forecast the different parameters which are not in a hand, we can generate more accurately the predicted amount of power. So appropriate prediction techniques and planning need to be used to overcome this one. It's also a method, we could say. Now, coming to way ahead, a lot of innovations and developments are going on. So, in the coming years, in future, we can have more innovations with the thermal generation. We can have more flexibility in the thermal generation systems as well. Thermal generation systems are being used for generating electricity, so we can make use of these thermal generation plants for incorporating for some other applications as well. So flexibility in this system can be incorporated by technological developments in the coming years ahead to use it more appropriately. And investment in solar power plants. A lot of solar power plants are actually being installed in India, but still investment in solar power plants can be increased in the coming years as well to get more and more solar power by using the solar power plants. And utilization of hybrid generation. We know that these renewable energy sources are not they are not generating power on the demand basis. As per the demand of the grid, they are not generating the power. So we can integrate different renewable energy sources. Like we can integrate solar energy, we can with the solar wind energy, and by integrating these different renewable energy sources, we can get more or less we can't say flat, but still more or less we can get a flatter sort of a curve of power generation by using hybrid generation systems. Not only solar and wind energy, other types of renewable energy sources can also be used. A hybrid generation method can also be utilized. It's been started off for right now, and in future we can have more hybrid generation systems of renewable energy in future for to cater the need of the demand of power requirement in a more appropriate way. The last one is trying with the storage options. Some technological developments can be incorporated in the storage options as well, wherein we can store the generated power with less cost. Some developments are going on, like some mechanical storage systems are being developed. Gravity based storage systems can also be being developed to be used to store the energy. So some if we come up with some storage systems which can using which we can save the power with less or if they are more economical, it will be more useful to store the power. So with this we'll come to the conclusion, wherein we can say that growth of the renewable energy systems is imminent, and the adaptation to the change is the need of the hour. Not an option for us, it's the need of an hour. Rather than pointing to the difficulties of renewable energy sources and the challenges which we have of integrating this renewable energy to our operating engine grid or to the operating grid, we need to come up with some options like how to overcome these difficulties and to go with some different methods to integrate by overcoming the difficulties with us operating grids. So monopolistic conservative days in power sector are over. We have innovative, economic and flexible power generation is to be taken place in the power sector in future. A lot of scope of is there in this power sector, we could say. So with this, I conclude my session.
Okay. Audience participants, is there any questions? Thank you, Hajra madam. Thank you very much for your sharing your knowledge with us. Anyone has any questions?
Thank you, participants, for your patient listening. I hope this session will be useful to you in increasing your in some way to improve in your knowledge. Thank you.
Thank you. We'll take break for 5 minutes, starting the next session.
Shridhar sir, are you there in the meeting?
Yes, can you hear me?
Yes, sir.
Yeah.
Okay, sir. Okay, sir.
Thank you. Thank you.
Now, next speaker, Mr. V. Sashira Rao, a highly experienced professional with experience, 15 years experience in the solar design and construction and telecommunication industries, over 3 years experience in the international procurement, 9 years in the solar industry, in the nearly 100 megawatt of grid and off-grid project, and 3 years in the telecom O&M. Professional experience, manager project engineering and procurement, renewables, Kirwins LLC, Houston, Texas, October 2021 to present. Educational profile, Master of Technology in the Digital Electronics Communication VTU, Karnataka. Bachelor of Engineering, the Institutes of Electronics and Telecommunication Engineering. Professional achievement, members of Institutes of Electronics and Telecommunication Engineering. Professional experience working for Kirwins LLC as a manager, project engineering, procurement, renewables, hostels, October 21 now till that. Work for the Lotus Energy Power Solution Private Limited as a general manager, project engineering and business development, November 15 to September 21. Work as a Premier Solar System Private Limited at Hyderabad, general manager, project October 12 to October 15th. Now, sir, please start your session.
Yeah. Can you hear me, listeners? Anyone can you respond? Jeanette, can you hear me?
Yes, sir.
Thank you, Lord. Okay. Yeah. Being a professional with respect to solar industry for about 8 to 10 years, specifically, can say that, yeah, what are the developments which are going on nowadays with respect to the panel, with respect to cell, and with respect to the design culture to maintain a good productivity in the sense, yeah, to catch up the efficiency and also to understand to tap the energy to the maximum extent, which our prime criteria is. So let's start with my presentation. Can you see my screen, sir? Hello? Yeah, can you see my screen? Anyone tell me?
Yes, yes.
Please, thank you. Yeah, innovations in solar energy technology, right? So that's one's the topics given to me, with breakthroughs and future potential also that to discuss with. So yeah, to start with, solar energy, harnessing the solar sun's power is a cornerstone of the global shift towards renewable energy sources. So, see, energy, it's diminishing, right? So, you can see the fuel, fossil fuels, and everything. So, even oil, to some extent, in one of the countries, in the African countries, where they definitely use generators to get the power then. So, there's all this diminishing one. So, it's only the sun which shines all the day in the sense, yeah, the sun hours, you can say that. So that's where we want to tap this solar energy to the maximum extent. So that's where the innovations have gone through in a major extent. I can say from the 4 decades, mostly from the 4 decades, right? So ongoing innovations in solar technology are continuously improving efficiency, because the efficiency factor is only the main thing which we want to highlight on, and by reducing costs, because the cost cannot be higher with the materials we use to generate the panels or the cells, and to manufacture the panels and everything. So the reducing cost is also one of the most criteria in it, and expanding the potential applications of this clean energy source also. So all these 3 points which I will definitely stress on by understanding, by giving you what are the research which is going on with respect to the cells and panels and other construction activities or in the full field, because being a person who has hands-on experience in designing and executing the projects as well. So I'll definitely give some points to what best we can do to enhance the production, to consume the production of the power, and then understanding more deeper into it. So the key areas of innovation which is going on should be, as I say, that it's advanced solar cell technology, enhanced solar panel design, and what kind of other designs which you can use to tap the sun to the maximum extent, and concentrated solar power advancements also that's going as ESP. Then smart solar and grid integrations, and not only the components which we use it. So it's all of that how best we use it is also one of the things which we have to stress upon to understand the technology, understand the design point of view on each side. So to start with, and yeah, advanced solar cell technology, if you can say that one of the topics on it. So this is the apart from amorphous silicon and polycrystalline formed of polycrystalline monocrystalline cells, which the world have used for last decade, if you can say that last decade and a half. So most of the solar plants of 80 to 85% plants have been installed with amorphous silicons, monocrystalline, polycrystalline silicon tapped based power plant. So in order to go a step ahead to tap this, because that's efficiency of the panels of those silicons have started from 12%, 12 or 10% to at times it has touched around 20 to 23% as of now, with respect to the monocrystalline silicon based panels. So if I go a further a step ahead, so if we can understand that what is perovskite solar cells, what is multi-junction solar cells, what is silicon heterojunction solar cells. So if we can understand this, so that the efficiency levels and the process by which they are manufacturing it, the research is going on in this particular kind of cells, where the interest will be more, because the efficiency is outbound, because it has increased from 30 to 44% to some researchers. They outrightly say that, yeah, I can say that it's 44% efficiency I can catch up on in another 4. So that's where I want to stress upon within my any of the topic says that breakthroughs future potential. So what are the breakthroughs in this? So but expect solar cells, I think 2025 from 1 or 2 points were plants which are already installed in USA, and the Japan and China I think is already been installed. I think the research with respect to the monitoring is going on there. So how best the production results, all the plant results will come up, and then they understand that what is the difference with respect to the percentage which we are coming up, the power production and everything, that will catch upon that. Of course, in another 2 years or 3 years, we'll come to know about the best, what the best it has given to the world. So these cells utilize a hybrid organic inorganic lead or tin halide based material actually. So offering potential for higher efficiency and lower manufacturing cost compared to traditional silicon cells. So perovskites, I'll just explain what kind of formation is perovskite cell is all about. And multi-junction solar cells, because by combining different semiconductor materials, these cells can capture a broader spectrum of sunlight. Hello. Yeah, broad spectrum of sites. Sorry. Yeah, broader spectrum of sunlight, leading to increased energy conversion efficiency. So another form of type of solar cells, which we wanted to use it to increase our efficiency levels. And even silicon heterojunction cells. These cells combine crystalline silicon with thin layers of amorphous silicon, resulting in improved efficiency and performance, particularly in low light conditions. So this is also one of the criteria where the light is low, and then what best we can use it. So these are the three major types. Well, because so many researchers going, but I have tapped on these three to understand more into it, because they've already wanted to get into this world with power plants, installations, and everything in the next 2 years. So how does perovskite solar cells looks like? You can see that what is the combination of it. So one is to understand the whole conductor electrode, and transparent conductive oxide is also there in between. There's a conductor. So perovskite is the crystal-like structure, right? So just like a diamond crystal-like structure, which the formation goes off. So how does this absorb light and generate electricity? So PSCs, short form, we can say that, so are made up of layers of materials that are coated or printed onto a substrate. So these are coated, printed onto a substrate. How does they work? They're exposed to sunlight. The perovskite, the PSC absorber layer releases electrons. So the electrons move to the whole transport layer, and then to the conductor. The conductor powers the connected connected load. So this it's a complex crystallized structure as perovskite cell is all about. So that's where the initial electricity with excitation of the electrons. So what are the benefits of it? So if we can, I can deeper into it. If you can go deeper into it, then I have to understand the structure of it, how does it looks like and everything. But I'm in a broader sense, I'm just touched upon. If you can go with the benefits, it's with respect to the solar streams, because whenever we compare with the 80% of the installation which is already done in the world, right? So it is amorphous silicon or silicon, monocrystalline, polycrystalline silicon cells and everything. So with respect to that comparison, if you can say that it is cost effective, because the manufacturing of solar cells can be produced inexpensively at lower temperatures also. And efficient. These are very efficient, actually, are more efficient than conventional silicon solar cells. More efficient, right? And that's what we have targeted for. So, right, 33% they say that as of now. I think it can as a bandwidth of increasing up to 42 to 44%. So there is a research which the professor or the assistant professors which can think of to understand this crystalline structure and then go into the research work as well. So it's can be designed and manufactured in a variety of ways. What are the challenges of it? So this is the challenges. See, operation timelines and long-term stability issues. So this is when this is exposed to the oxygen, when it's exposed to other atmospheric conditions, this is prone to get a degrade. So unlike the silicons, that's where the challenge is. So this hardness, the perovskite, whether we can fix, whether we can mix up with some other material to get it harder, and to get this material to be prone or to withstand all the conditions, atmospheric conditions, so that it can last long. That's where the point the perovskite is lagging somewhat. here on this. So still ongoing research is focused on improving the stability and efficiency of the PSACS. So the still research is going on, and this is one of the areas where most of the worldwide people are thinking on that. So next, if I go to the multi-junction solar cells, so that utilize multiple PN junctions here. If you can see that NP, 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 that's right, the combination of NP junctions made from different semiconductor materials. So why this? Uh, why this efficiency is getting increased is the cells, the multi-junction cells or the perovskite cells, perovskite cells, PSC cells, what we use, they will tap on the different wavelengths. That's where the efficiency of it's getting broader, it's getting higher, and also the timelines of the sun hours, because normally we calculate the sun hours as 6 sun hours, 6.5 or 5 sun hours, and average we could put together. So that is if we can tap for more hours, morning another 1.5 hours and evening another 1.5 hours with a lesser lower light, then we can just generate some more electricity of that. So we can add some units to it. That's where our main intention would be, because see, we cannot sleep overnight and then can for only 4 or 5 hours generate electricity, investing more on the installation costs and everything. So investing more on the projects and then coming up with only 4 to 5 sun hours a day, because it's only the 20% of a day of hours which we are generating it to the max. But it can be 6.5 hours or 7 hours in summers. It can be 3 hours or 4 hours in winters. So that's where in average we can say the 4.5 hours, 5 hours. Normally it depends on the region to region of the sunlight productivity or sunlight irradiation levels. So this multi-junction solar cells absorb wider range of wavelengths. By this idea of understanding this, because see, each NP material is different here, because the top cell might be made of gallium indium phosphate, which captures blue and ultraviolet light. The middle cells could be composed of gallium arsenate, which absorbs green light. The bottom cell is typically germanium, designed to absorb infrared light. So several researches are going on different. See, not only this top cell, middle cell, bottom cell. It can be used for several cells also, right? NP junctions can be multiple. Like I can go for 10, 12, 13. So by the compositions of the material, what kind of wavelength you're tapping at. So we can see here. You can see my cursor, but this is the wavelengths which have gone through. So the tapping of these wavelengths definitely gives you more electricity on lower lights. That's the intention of the multi-junction solar cells are. So the key points would be then it can be a higher efficiency, specific portion of this light spectrum. So tapping of the light spectrum, allowing for better utilization of the entire solar radiation. So higher efficiency due to their availability to capture more light across a broader range of wavelengths. So multi-junction solar cells can achieve significantly higher efficiencies than single junction cells. So this because of the combination of this, but the choice of the material selection is also important. See, this is not fixed. So how best you are using the bandwidth of it. The top junction, the bandwidth is 1.7 to 1.10 volt, and the middle junction is what is it, and bottom junction is how much. So all these things, what light do you want to tap upon? These all things. So that's where the research is touched upon. So not only three, as I said, it's not only 3 NP junctions, but it's multiple NP junctions also can be used. So while highly efficient, multi-junction solar cells can be more expensive to manufacture than single junction, so due to the complexity of the design and fabrication. So this is where the complexity has come into picture here. So if it is complex, then the cost of manufacturing the cell, definitely it will be more. So that's that's where this is research and the cost effectiveness. That's always fights together, right? So whenever the cell is good or bad, or then it's not working fine, why it is not working fine, then they do researches on that. But the multiple multi-junction cells, so the perovskite is also the material which is available in the world for the lesser price and everything. It also depends on that. So definitely, it's all the debate is always open with respect to this. How see if from 15 efficiency to the 35% efficiency, if you're increasing the tipping increase it 125%, so how much amount you're going to spend for that, right? So it's also more important in understanding that. So so cost reductions is also one of the criteria, and the metal which is used for each junction is also getting is searched upon. So design and what are the applications in this multi-junction solar cells? See, all the space applications are used multi-junction solar cells. If you can see a good figure of a solar cell on a satellite or on a space application, this one space, and you can see that solar cells spread on the wings. So those solar cells spread on the wings of the multi-junction solar cells, well suited for use in space where high efficiency and reliability are critical. So we can reliable on more on that. So this here, these cells are also used in the concentrated solar power, which I'll also touch upon in the next slides. Can be used in concentrated solar power systems where sunlight is focused onto a small area to achieve even higher power output. So these multi-junction solar cells are also there, used in such applications. So another topic which we can go, silicon heterojunction cells. So this is also which are one of the topics which we have to talk, because with respect to the heterojunction solar cells, the cost is more. Then this is another area where we can understand we can go for this huge manufacturing because of the less price than the multi-junction solar cells. So that is heterojunction solar cells with intrinsic thin layer. It has an intrinsic thin layer, or HJT. It's called as HJT solar panels, or a type of photovoltaic cell that combine crystalline silicon and thin film technologies to achieve high efficiency. So if we can understand this, silicon, crystalline silicon and thin film. Thin film is also one of the technologies because it's combination of that crystalline silicon and thin film, which is already there in the market. So we are making use of those cells and combining it together to get this efficiency, to increase in the efficiency of the panels. So the structure, depositing. So this, how does it looks like? So you see. Solar cells. So there's the combination of this compositions on this n-type amorphous silicon, this grid lines, and then transparent conductive oxide here, and p-type amorphous silicon has also been part of it. So this different combinations will have an different naming. Passivated, say this PERC solar cell also it's in the market actually as of now. The PERC solar cell also in the market. So it's a mono PERC, it's called as. So I think from 3-4 years, I think people have been using this. And tunnel oxide passivated contact top solar cell, so top one solar cell, it's called as. So and then integrated back contact solar cell. So these kind of solar cells have been getting manufactured as the silicon heterojunction cells, and then depositing thin layers of non-doped amorphous silicon on both sides of an n-type monocrystalline silicon wafer. So not to go deeper into this technical aspects, I'll definitely make you understand that the efficiency is more than 30% for bifacial models. And see, now it is the efficiency has touched upon 26 to 28%. Nowadays in the market, you can see in this. But if you can use for bifacial models, I'll also show you what are bifacial models. We can touch more than 30-32%. So what are the applications of it? With limited space or large generation capacity requirements, they are also being developed for use in vehicle integrated photovoltaics. So most of the vehicles, I think, if we can see in the next decades, right, solar, I think this kind of cells can be used in the vehicles also. So replacing silver with copper for the electrodes and could reduce the cost reduction. Also one of the criteria where the research is going on for the electrodes which you're talking about now, which we can replace with copper for electrodes, could reduce the cost of SJ solar cells. Is also one of the main points which people are thinking of. So next week we'll go for the cells. So these are the 3 cells where I have selected it, but most of other kind of cells are also getting researched on that. But I have selected this because of taking considerations with respect to the manufacturing, mass manufacturing, the cost effectiveness, and the durability. Or at least because when you install a power plant, at least it has to withstand all the atmospheric conditions for 20-25 years. So which I've taken this 3, and the in applications with respect to other areas as well. So space in vehicles, and also in the ground, because even the land is also that it's here it has become the costlier, right? So how best we can use the land to tap more energy. That's also one of the criteria which I've selected for 3 cells. So coming back to the seed, there will be, as I explained earlier, that there will be cell, there will be panel, and there will be components of the plant, where all these 3 should combine, and I should come up with a design prospect so that we can achieve our goal of generating more electricity with cost effectiveness, and using all this nowadays the IoT, Internet of Times, and then are also this if we can even EA also can place vital role here to maintain a plant. So all these things will add up on to have this solar related business models to increase and to tap the energy which is free in the world. So bifacial solar panels is one of the panels which we can regular conventional models you might have seen, right? So I think it's an angle design with respect to the latitude what we do it, and then it's a standalone, and with an even 360 degrees rotational panels, and single and multi, and then 180 degrees rotational panels with respect to the sun, and all these things that just come up. So if apart from that, if we can use some panel design, the different panels, right, how we can use to tap more energy, because the energy yield, what we call with the bifacial solar cells panels, is around 30% and more these days. So even we can use the transparent and flexible solar cells on our roofs, on our patalas, on our verandas, and where the exposure to the sun is more, on your penthouses, where we can tap upon this. So that's also one of the areas where the research is on. Because see, that's where, because most of the people will definitely cover a sheet, right? So if you can cover with a solar sheet, then it adds up to your aestheticness, and also to generate power. So that's also one of the areas which the people are highly motivated or highly interested to work upon. So these innovation allows for the integration of solar technology into windows, building materials, and even wearable devices. If you can wear some shirt with respect to that, definitely it is another one, is expanding the potential applications of solar energy. And people are thinking of the aestheticness of why I'm saying stretching component. There are solar skins also, right? So I'll show the photographs, which how does it looks like. Allows for customization of the appearance of solar panels, making them blend seamlessly with the surroundings and enhancing aesthetic appeal. So this is for solar skin. So this is bifacial solar panels, which I've said, right? So both sides of the this one panels are upward and downward sides. If you can place it on a standalone thing like this, then definitely there will be a reflected light from the direct sunlight, the scattered sunlight, the scattered light, the reflected light. So even the downside of the panel also can be tapped upon. So that's where the bifacial as solar panels have come into picture. And then this is giving more yield, energy yield, than if I say that monocrystalline PERC models gives you 22% of the energy yield, then it definitely it will cross another 30 to 40% more if you can use the bifacial solar panels. So I was talking about the transparent and flexible solar cell, how that looks like that, right? So these are the transparent thin film, even the solar panel. It just looks like a roof, but it's a solar panel there. So these are the applications which the world is looking upon to understand, right? To tap on, and these are all the research areas. Whatever I'm touching upon, these are all the research areas, and then you can deeply dive and then understand, right, what best we can take it. So if you're interested in solar, understanding all these panels, cells, the panels, and the grids and the small microgrids and smart inverters and everything, they're all the research parts. That so much is going on in different in every other world, in other main countries. This is what is going on, and this is a solar skin which you're talking about. So the color of the building can be matched upon with solar panels on top of the solar panels, and this definitely will not give you if you can go for the bifacial solar panels, and are best used in this bifacial solar panels are best used on in commercial utility scale projects where they can be elevated and angled away from mounting surfaces, allowing sunlight to reflect into the back of the panel. So that's what I've discussed this, but it cannot be used for the residential projects, which is a compact design there, because the space is less, and then you need a more space from panel to panel or the row to row, so that the reflected light can tapped upon. So I think it is more of a commercial project, commercial utility scale, higher utilities, larger utility scales projects which can use it. So in this transparent panel looks like a clear glass, but let light through this regular windows. But they are made of with a solar glass that absorbs ultraviolet and infrared light, and specific the wavelengths of ultraviolet and infrared light, types of light that aren't visible to the naked eye. So these lights are not visible to the naked eye. If you can see the ultraviolet and infrared band, you cannot see that. So then turn these into renewable electricity. So this definitely is it's a very good understanding of this transparent flexible solar cells to get into the Indian markets, and then tap on these kind of things, because might be the cost will be higher at the earlier stages, but when the mass manufacturing will comes into picture, definitely it will cut down the cost. Unlike traditional solar panels, a flexible panel surface isn't covered by protective glass or metal. This is not protective glass or metal. This is a thin film. Let's just like it can be rolled upon. But these kind of films not only transparent, because see, thin film is used in defense applications where you go to deeper extent to the forest or to the desert areas to longer periods. Then you don't have an electricity there. Then definitely you use thin film, and that's kind of, you can compare that with that kind of things. But it's more complex and more complicated, and a more efficient generated panels like this. So even if you can go with solar skins, right? Solar skins, most of the people in Australia, in America, and also to some extent in UK and I can say in Australia and China, Japan, these people want to use it. They don't want the house to look like a solar panel packed up. So they want to use this solar panel with aesthetics also in it. But this aestheticness cannot compromise on the quality of the tapping of this sun. So definitely, and also this is helping to see, the generation definitely will be the same, but this is also helping in the same manner to tap this one for longer years. So it is just like a protecting the top of glass of it, and then making it looks aesthetically also good. So this is also one of the areas where I have where I was searching, then I just got an interest on that, so to show you. So this is also printed designs and often made to mimic the look of the rooftop. So be it shingles, tiles, or another type of material. The primary objective is to make the panels blend seamlessly into the surroundings, making them less noticeable or obstructive. What sets SolarSync apart from the other aesthetic solutions is that while they change the appearance of the panels, they are designed to have a negligible impact on the efficiency of the underlying solar cells. That's where my point was. So these skins are made from durable materials and can withstand various environmental conditions, ensuring they last as long as solar panels. So this degradation factor definitely will come down because of the solar skins. Can anyone say? Can you hear me, sir? In between, hello. Hello.
Yes, sir, we are hearing you. Yes, sir, we are
We
hearing
can
you.
hear you.
Thank you.
We can
Right,
hear
because
you.
the crowd is calm. I understand that. So, of course, I'm not getting bored, right? So, all well.
Yes,
Yeah.
sir.
When if you can come up to this solar concentrated solar power, another advancements which is going on in this world is the design of solar power plant, right? So, what are this? See, they have the advanced mirror designs, improved accuracy, and efficiency in focusing light onto a receiver, increasing temperature and efficiency of energy conversion. Why this kind of technology has come? Why? Because the sun hours is only 6 sun hours, as I said, 5 to 6 sun hours, right? So what are the rest of the 18 hours? Why you are not using it? Are there any technical way we can add upon or and touch upon, so that we can use that also, that those hours also, the most of the 16, because see, I think the if you can say the concentrated solar power advancements, definitely CSP type of plants, they're yielding out around, they're giving out 16 hours they are generating it. Even though the generation the generation, the peak hour generation and the less hour generation, definitely it varies from hour to hour, but the 16 hours is a huge actually. So when you are investing in a plant and giving you 16 hours of generation instead of 6 hours of generation, it adds upon to your energy, it adds upon to your break even point of view. So this is advanced mirror designs, improved accuracy, efficiency of energy conversion. So thermal energy is also one of the areas and the technology which the CSP plans to store heat for extended periods, enabling electricity generation even when the sun is not shining, addressing the intermittency challenge of solar energy. That's where I said that when the sun is not shining, also that you can see the power is getting generated. So this is also one of the areas where this research this is going on. And hybrid CSP plants also, combining CSP with other energy sources such as natural gas to provide a continuous and reliable power supply. So if we can see that, so whenever there is less sunlight, and if we can add another wind energy to it or another natural gas energy to it, so it will become as an microgrid, or we can get a multiple source of power which is getting generated with respect to other renewable sources. Then the 24 hours power supply can be given to even an island, right? An isolated island where you cannot take your electricity or overhead lines and everything to give them electricity for that. So that's where the places where the special interest is going on with respect to this kind of design. So how does it looks like? So how to advance. So even thermal energy storage, we have non-efficient solar concentrators, new designs such as Fresnel collectors and other power sets also. But how does it look like? How to advance mirror design? So what are this advanced designs we have as of now? It's a parabolic mirror design I have, materials and coating design we have, Fresnel reflectors we have, solar power towers we have. So how does this one taps upon? So there will be a central receiver which all this will be pointed out to the single contact, so some single point. So all this solar tracking reflectors will be designed in such a way that it concentrates on a single point, right? It will be roundabout. I think I can show that picture as well. So this is one of the major plants which in China this is built up. So this you can see that, right? So the light is getting concentrated to a single point there. So this is where the light focusing on a single point, solar tracking reflectors give you and reflects to the light. So this to the light, this functions upon. So that light convert that heats up this tanks. It's in the hot heat tank and cold tank, and then that stores the energy of heat with respect to the molten salt. That heat can be used to evaporate the water and then start the turbine. So like the turbine, and with respect to the turbine, that heat is getting generated, the electricity will be generated. So this is also one of the areas where these installations are going on, because the cost of the material of the reflectors is very less. It's just a glass, right? So for reflectors, it's not unlike another combination of the materials. It's not like that. It's not that complex. So this is thermal energy storage is also there. And then if you can come up with the designs part of this, there are parabolic mirror design and materials and coatings design and Fresnel reflectors design and solar power designs. So there will be mirrors which can be pointed out to individual to the one point and then reflect to the main point. And there will be reflectors which can tap the light, and every reflector can pinpoint to a single point. It's pinpoint to the same central receiver there. So that's where the LC is also getting generated, and this expansion new part. See, this is where molten salt storage, so called government policies also should add upon to it. So that's where my intention would be, because see, if the cost of the power plant will be less or in compared to the same to the solar power plants, why we can't be encouraged this kind of things? Because see, more hours it is getting used upon, right? So more sun hours can be used, or more other light hours can be used. I can't be saying, because in the night also you can generate this. So light hours, it's called as light hours, right? Sun and when it's sun, there is light. So if this moon also, there is a light. So if you can use more sun hours, light hours, then definitely it's just a viable project which you can take it into consideration and then move on. So this is getting expanded into new markets, because gain traction in the regions with high solar radiation and growing energy demands, such as the Middle East, North Africa, and parts of Asia. So this is getting spread out in South American countries also. I think I've seen in Argentina and Peru, and to some extent, the plants are getting installed. This technology makes it feasible to produce electricity even when the sun is not shining. That's what I said. When the sun is not shining, also it's the tapping of light also can be used. So other advancements include, right, a wider use of thermal energy storage, improvements in material science. There's also one of the criteria, and that because the storage of heating is also one of the molten salt, which which I said that this is where it's getting stored. Heat is getting stored, and then it is getting converted into a vapor with respect to the water which we flow upon. Then the turbine will rotate, and then the electricity. So there will be some complexes, but in that, but normally what we generate from the fossil fuels is like coal and then other things, and the water also. When the water produces the turbines, there will be mechanical challenges, definitely, yes. But yeah, this can be there are so many researches which have been gone through in that, and then this can be a viable project to take into consideration, and also research area can think upon. And what I said, it's key points. What are the key points in thermal storage here, right? Molten salt storage, which I've around upon this the pink figure. Two tanks will be there. There is the hot tank and the cold tank, and then improved heat transfer fluids have to be critical. Installations also should be used while transferring the heat to the operating turbines and everything. So, and advanced thermodynamic cycles also should be used. Grid stability, because of the combination of this, there will be not much variations in the voltage. So the grid stability is maintained all the time. There's also one of the criteria of the transmission of power here. So even dispatchable power, right? It can be dispatched in phases. So whenever we want, we can increase it. Whenever we want, we can decrease it. So this is also because in that solar energy, we don't have that options there. So whenever we have a sun, we have to use it, or we have to spread it, or we have to send it. Whenever there's a sun, we have to give it back to the control rooms and everything. So that's where this kind of technology, I think it has to be thought upon, and also government policies should come up. And yeah, as I said, that hybrid CSP plants. If you can see this is this where I was talking about the CSP plant and then thermal storage and everything. And these are the tanks which can be heat is stored in it and then it can produce. And these are the solar power plants which is installed around about here. So there are some solar power plants also, which can be said as, yeah, a combination of the plant, right? So one is say a hybrid, then another is solar. So whenever there is we can balance upon whenever there is a sign like, because it's a desert, we can see that the area which we installed it, why they have installed a hybrid, the picture says it all. So this is also one of the good areas where we can think of for the future potential of this innovations and future potential on this. So hybrid CSP plant advancements also, that so there will be thermal storage. See, every topic which I've kept it is on, there is a specific research is going on to improve further. So what kind of energy storage, thermal energy storage we can think of, and how are they? So instead of salt, whether other metal can be used or not, modern salt or others can be used. Solid particle receivers, hybrid CSP PSP plants, right? Hybrid, what I have shown at that CSP and even PV systems, also combination of it. The modular design, whether how best we can use the tapping of the design, integration with other energy sources also. It's also one of the criteria which we're doing. Fossil fuel switching also there. Cost effectiveness also thinking of. So these are the areas where we can see of. So I have started with respect to the cell there, and I have discussed with respect to the panels and how the orientation can be and how that. So I have not touched upon the conventional part here. I'm just talking about the future potential where we can think of to understand, to gain our knowledge and go with respect to the world which thinking of, right? So the people have always been sticked upon for this silicon crystals and monocrystalline polycrystalline panels, the standalone panels or the rotational panels there, right? So now I think shift is already been into 2025. I think this is the year where you have to use an innovative cells to tap more energy on, to get the more efficiency of more than 30% I'm talking about. So this silicon is a stagnant of silicon, right? It will be 28, 29, not more than that as per the technical aspects. If you are going ideally also, it can be tapped upon 26 to 28, not more than that, if the material is also pure and everything. So if you want to increase for more than 33%, I think this kind of innovativeness or this kind of different thinking of the designs which we have to come out to, because even Japan, China, I think China is well ahead of the world, which the way they use, even America to some extent, yeah, they're getting up with the huge, larger plans into picture instead of conventional side as well. So in that scenario, I am coming into the components of it, right? So I've touched upon cell, panel, and how best we can orient it, and now the components of it. So what are the components which can play a vital role? So these components definitely can be parts of generation. When you're generating, definitely it should have an inverters to change from DC to DC or DC to AC, in what are the way you use it. And even the microgrids, right? The microgrids definitely will have a controller part of it. So the controller also should have embedded with embedded systems and everything. So microcontroller should play a vital role. And the way you use it, see, every day, every hour, every day will not be the same day for you, right? So we switch on the AC once and we switch off AC once and you use another heater at once, right? So the consumption will vary with components that you use it. So as long as you're using it, see, if you want only the renewables to be used, then you should have a windmill, we should have a solar, we should have a solar heater, water heater to add up, and then to integrate with respect to all this, with respect to smart inverters and microgrids. So the controller has to do the job for you, right? Whenever you're using it in a different, with a different source of generation of renewable energies. So, and in also, why have another added point here in this integration factor, right? Enabling greater integration of distributed renewable energy sources like solar. So even the why I've added Internet of Things, this is where giving, because a person like me giving more data to me to understand a plant. See, for example, I worked upon 2020, 2012 or 2011, the Asia's largest solar power plant, which was installed in Gujarat, right, in Charanka place. That's where, if we can read that for the last, because we have a data of 13 years now, the plant's data of 13 years now, how this component is behaving, how this panel is behaving, how the generation is getting used, or what is the degradation factors we have, because this is the atmospheric conditions of that particular place. And all these things will come only with respect to the Internet of Things. When you are sitting here and then analyzing the data of the yearly data of each year data, then you understand that whether my panel, manufacturing panel, as how much it has given generation of electricity year by year. What is the degradation factor? Whether the degradation factor, the mentioned in the panel, in the pamphlets of given panels, whether it is 0.2% or 0.3% or 4% or 5%, right? The data gives you a complete picture of it. Subtracting the condition, or subtracting the incidents which will happen in the plant. So that's where the Internet of Things also, I think, in this AI generation definitely will play a vital role now. So innovations should come up in these areas as well, which why there's a huge potential as well. So context of embedded system in a smart inverter. So when you use this, right, when you have a distributed generation system with you, when you use this kind of smart inverters, definitely you can tap whatever the tapped energy can be used properly. So that's my intention, was to show it. So generation is to some extent. So research is going on, and you're using the best panels. But how best you're using the power which is already generated there? This is also one of the points which you have to think upon. So this is also one of the play criteria, and researchers are on in it, and then they are also doing it a great job, and understanding the power electronics, and understanding the embedded systems of power quality, protection, and communication. Because the quality is also, because the grid stability is also very important when everyone is generating this with renewable energy, and the grid is not in a position to take it, then the energy generated will be waste. So smart inverters give you increased efficiency, grid interaction, remote control. I think you can control it when on and off, whenever they need it, or whenever this grid is not in a position to accept it, you can stop it. You can remote monitoring it. Advanced safety features. You can even detach one of the inverters which is behaving odd or behaving erratically. In one of the inverters, you can switch off. You can isolate it with respect to your software, and you can tap on the real-time data. And all this will come sitting in one of the places, and then adding on, and then you see, not only this, it's small inverters. If it is very smart, then definitely the behavior of the inverters can also be studied, right? So in other sense, we can say that if one of the plugs of one of the panels, or one of the strings of the plus and minus is behaving hot, so it will not give the same voltage, the same voltage when it is loose, when it is ruptured, when it is rusted, and everything. So if you can study that string by string analysis, then definitely you go to the particular string in the when you have a plant in 50 acres or 100 acres, where do you go and check that whether it is good or bad, or whether it is behaving properly or not? It's only through the smart inverters data only you can think of, and then go and touch upon the same inverter and the same link up, and then change it or unplug it, or you can repair it, and then keep it in and make it happen in the make it ideally work. So that's also one of the areas where you have being an installation guy for 7-8 years in the ground level, I understand this. So what is a microgrid? So this definitely have that, because we should have a UV chargers, and several applications are coming up, right? So even the atmospheric conditions are changing day by day. This summer is not summer, and winter is not winter. So in winter you can see summers also nowadays. So that because of the atmospheric conditions, definitely you should be ready to understand when you are going within distributed systems, renewable energy and everything. So when you want to store it, when you want to detach it, when you want to generate, and when you want to add upon to your things, definitely there should be a controller. There should be a what you call generative AI kind of thing controller, where it gives it understands the same, right? Whenever there is a peak demand, it gives it. Whenever there is a low demand, it cuts on. So this is also one of the areas where uh, you should always think of. So are different places getting electricity and different places getting used to it. So how best we can give them with a quality power is also one of the areas where the microgrid controller can be uh, used upon, right? So and Internet of Things. So that's what I was thinking of. So without this, I think the research cannot be complete, right? Research can be happen with respect to the material part, with respect to cell part, with the panel part and everything, but the one which you have already into the market, and then the panels which you want to understand that the behavior of them and everything, and all these things only come when you have a data of the previous years. How best we can improve it, because it's technology is new, right? So it's not it's just a 3-4 decades old. So if you want to improve the technology, if you want to touch upon the innovation part and the and understand the future potential of it, definitely this Internet of Things and data analytics should play a vital role. So I think if the AI comes into picture, then definitely usage of AI has also been thinking of and in one of the in plans nowadays. So then if that comes up with, definitely this Internet of Things, definitely IoT, definitely will play a vital role. So what does the IoT will do in a plant, right? So it takes the sensors data collection, it takes the wind data collection, it takes the irradiation level data collection. So everything just have a monitoring point, I mean, monitoring equipments. So from all these equipments, it collects it and gives that set whether with respect to this condition on this particular time, whether our panels have been given a good generation or not. If not, what is the fault? So that is also can be real-time monitoring, and then we can see with some formulas we can also assess on the plans which is getting generated, and predictive maintenance. That's what I was testing upon, right? See, one of the inverters or one of the strings which is behaving odd, then how we are generating, how we want to identify that. So it's only through data, with real-time data, which is monitoring real-time monitoring data, which can be seen it, which can be analyzed it, and then it can touch upon the same inverter and go to the same inverter, and then it can cut down the time as well. So and then performance optimization, right? Yeah, this is also one of the areas. So that's where when you have the sensor data of all the things, right? Even the dust, the collection of the dust, even the humidity levels in the one, even the strength of this, the irradiation levels of it. So even temperatures of it, absolute temperatures of it, and all these things. If you can have the combination of it and use it in a formula wise, definitely, I think the behavior of the panels, the behavior of the cells, the discoloration of the cells, that there's so many things are there when you go into your plant, right? There will be spots which will come up, there will be excreta of the birds which will definitely which will degrade your generation part. So why it is so, rather than what you call going around about for all the plants, you cannot roam around 100 acres plant every day and night. So it's only through monitoring, I think you can tap on that remote